Hi there. Sometimes there are water supply pipe leakage problems or a redesign that I may need to do. And so for that reason, I bought this hydraulic pressing tool from the company iGeelee in China. I ordered this pressing tool with V-profile crimping dies of size 15mm, 20mm, and 25mm. And to test the pressing tool and whether the crimping dies are suitable, I have here two sections of 1/2 inch diameter copper tubing. At the bottom end, I have a compression union to attach this to a bib garden tap. In the middle section to join the two copper tubings, I have a Metpress DN15 straight-coupling. And at the top end, I have a Metpress DN15 end cap. So join me in this video as I give an overview of this pressing tool and test its capability on this very simple short setup. And at the same time, I also want to test these Metpress V-profile couplings and see me carry out the test. Let's unbox this iGeelee hydraulic pressing tool. In the top lid, there is a tube cutter. It says that it cuts from 1/8 inch to 1 1/8 inch, which is 4 to 28mm diameter. There is an instruction manual for this pressing tool, which is model HT-1950. And inside this pack, there are spare replacement washers and circlips for maintenance. This is the main body of the HT-1950. This is the head, or I would call it the jaw. And in my case, I ordered 3 crimp dies. 1, 2, 3 here. The first crimp die says VAU15. I believe it means V profile for Australia. This is what it looks like. This next one is VAU20 for 20mm. This third one is VAU25 for 25mm. The crimp body, it has the pump action handle, and there's a spring-loaded pin that pushes it back up. There's a pressure release valve. It says work. To close the valve, it says reset to release the valve. When I keep this tool, I turn this to reset in order to release pressure. At the rear end is a nice aluminum tubing with a null grip. If I turn this anti-clockwise, there's an O-ring seal. This is a rubberized oil reservoir, and at the tail end is a plastic null plug where if I want to fill up or drain and refill the oil, I would remove this drain plug, drain the oil, and then fill in new oil and refit the plug back to the end, and then refit the blue aluminium rear body and tighten it till the O-ring is sealed. At the front end, there is a black plastic lever. I can turn the lever anti-clockwise or clockwise. There is a groove in this plastic that allows it to catch the aluminium body and holds it in the position. If I turn this anti-clockwise or clockwise, it releases it from the catch and allows me to, at the 12 o'clock position, release the pin. The pin will not fall out, which is good. Then I can take this head or crimping jaw, fit it in so that that hole is aligned to this hole, and it does not matter which side I fit this. Then push the pin in completely, rotate the lever till it's back at the 6 o'clock position, and that locks it in. On the blue parts of the jaw, there is print text which says for copper pipe or stainless steel pipe, but it will have to be thin wall stainless steel pipe or PEX pipe. And I have here the VAU15 crimp die. To fit the die, on the back end of the die there's a slot. This slot needs to be held in by this pin. So pull this pin out by pulling on this knob outwards. Slot this in. Release the pin, and the pin will be caught in the groove of the die. Do the same for the other side. Squeeze the jaw open. Pull the pin, and both the crimp dies are locked into position. If I squeeze the jaws open, then when I want to use the tool to press, I turn this knob clockwise and press. But there is no press fitting in there. I will not do that. I will release the pressure valve. And the documentation wants to never operate this handle and apply pressure when these crimping jaws and crimp die are not attached to the body, because it will cause damage. And the head can be rotated, so that makes it convenient to access couplings that are in awkward positions. The user manual says that this pressing tool is capable of applying 6 tons of pressure, and without the crimp die it weighs 7.7 pounds. This length is 20 inches. This is 4.05 inches. This is 5.5 inches. And the length of the handle is 10.62 inches. The user manual states for the operator to read the instructions manual before using the tool for safety reasons. These two short copper pipes are not completely straight, but that should be okay. I'm repurposing them for this test. They are all recycled tubing. The first connector I will assemble is this 20mm female iron to 15mm copper compression union. Please note that I am not a plumber. I'm doing this for myself as a simple DIY project and test. Take note that in many countries around the world, any water plumbing works must be carried out by approved licensed plumber, and any gas plumbing works will also have to be carried out by an approved licensed plumber. So do not carry out work which you are not authorized to do so. So engage a proper registered licensed plumber to carry out your water and gas plumbing works. Now, because this pipe is a recycled pipe, its circumference is not completely round. So normally when using a compression union, whether with a plastic or copper olive, some plumbers do not apply any Teflon tape or liquid sealant dope. But for this test, because this is not completely round, I will apply some liquid sealant dope. And the liquid sealant dope has to be watermarked approved or approved for gas plumbing accordingly. I don't want to get the dope into the tube itself, just on the surrounding outside. So the plastic olive is now inserted, and on this side there is a chamfer. This chamfer will press against the plastic olive and compress it, and that should compress the copper pipe. Extend it longer so it goes in a bit more. And I'll apply some sealant dope on the front of the olive. On the outside of the olive. and on the rear. The dope is very sticky, that's why I have my glove on. Now if I slot this in, the copper tubing comes up to that surface, which is just nice. And I join it. That's the copper tubing. Now I have to tighten this nut and this nut. To do that, I have here a pair of Wolf pliers wrench. The design is different from the typical simple adjustable pliers because in the simple design, the lever arm is connected to the lower jaw, and therefore when that pivots, the lower jaw actually rotates and is not moving parallel to the upper jaw. In this design, there is a cam, and this cam allows the lower jaw to move parallel to the upper jaw. And to adjust it up and down, I press this knob, goes up, releases, locks back in, press it to adjust, press it to adjust. And if you take note of the jaw movement, you see the lower jaw moves parallel to the upper jaw. It's a good design. So I'll use the smaller pliers to grip the smaller nut and the bigger plier to grip the bigger nut. I've adjusted them to their correct size and turn it clockwise. Not to over tighten it. I think that should be adequate. That's not going anywhere. That's good. This is the Metpress PFW001 Copper Straight-Coupling #1 for DN15. It is also watermarked. This is the Metpress PFW122 end cap for DN15 diameter. Now to fit these two copper tubes with this coupling, they should go there like that. That middle groove should be where the joint is. And if I push the copper tube in, it is tight in the copper tube. There is a black O-ring at this end and one at this end. When the press fit tool crimps this, it is a rubber O-ring seal that provides the water seal. I'll mark it approximately where it would be when it's pushed in. There, that's the mark. I'll push the other one in. They're both at the mark. That's good. Now to fit it into the tube, I'll press this side first. Put it into the slot. Close the jaw. Make sure it's in the slot. Make sure also that the pipe has not moved out. Then lock the pressure valve. And I can apply downward pressure on the pump. And as I'm pumping, these two pistons are moving forward. And as the pins move forward from my pumping action, this pushes the lever out and causes the jaw to pivot down to squeeze the coupling. It will take a few pumping actions, but I can see the jaw moving inwards. Note the jaw is moving down. Right, I heard a click sound. I'll release it. The pins move back, squeeze. And I can see the crimp pattern. 1, 2, 3, 4, 5, 6 on this side, and the crimp pattern 1, 2, 3, 4, 5, 6 on the other side. That's good. And that mark is still there at the end. So this should be crimped. And from the crimp, the blue plastic cover has come off now to crimp the other side. Because there's quite a lot of force involved, it certainly helps to have this bottom arm resting on something. Or if you have strong arms, then that's okay, you can handle it. Open the jaw, put the blue ring into the groove. Make sure the tubing is pressed in. Lock the pressure valve and pump the lever, and the pin moves forward. The jaw is now closing down. That's good. I think that's tight enough. Release the valve. Open the jaw. There we are. Let's crimp on this side, and I can see the crimp mark on this side. So it looks like it is crimped adequately. Later, my water pressure test will test it is successful. Last one to fit is the end cap. Push it in. Put a marker mark around it. Open the jaw, put it in the crimp die. Lock the pressure valve. I'll support this so that it is not tilted. And now pump. Alright, I think that's one more pump. That should be good enough. Release the pressure valve. Open the jaw. And here we have, it's crimped on this side and the crimp on this side as well. So that's good. I'm now outside the house at my garden water beep tap. And be sure not to cover the last 1 or 2 threads with Teflon. My test copper pipe will fit to this male thread. I've put Teflon tape clockwise winding and avoided the last 1 to 2 threads. So now this will go like this. And I'll just use my pliers wrench to give it a little bit of tightening, not too much. That's it. So this is now fitted. The final step is to test it. Fingers crossed, hope that it does not leak. Turn on the tap. Now to turn this on. It's fully turned on. There's no leak from here. There's no leak from here. There's no leak at the coupling. That drip is from this tap because this lock is faulty and leaking. But as far as this test pipe is concerned, there's no leak. There's no leak at the compression union end. There's no leak at the press fit straight coupling. And there's no leak at the press fit end cap. Success. Just to prove that mains water is on, I'll turn this one on. So mains water is running. This is in on position, but there's no leak. So as far as I can tell, this hydraulic press fit tool works. The VAU profile crimp dies work, and the two Metpress V profile DN15 straight coupling and end cap work perfectly. I'm pleased. So I will be buying more of these V profile couplings to keep in my inventory. I hope you found this video useful and interesting. Do hit the like button and subscribe to my channel for more and help the channel grow. Thank you so much.